let's look at this graph of a polynomial function for an activity that you'll be doing that's going to be matching cards up to 4 different graphs. So the information that we want to get out of this, the first thing I'm going to look at is where are the roots. So if I look at the roots are the x-intercepts. So I have one here at -2. We'll call that 1, 3, and 4. So let's list out the roots. The roots are at x equals -2, x equals 1, x equals 3, and x equals 4. Now one thing that you want to take note of is that this root at x equals -2 has a multiplicity of 2 because it bounces there. So we can actually take these roots and we can build this function into its factored form. By taking each of the roots, x equals -2, and getting that back into its factored form. So to do that, for example, we would take x equals 3, and we will subtract 3 from both sides of that equation, giving us x minus 3 equals 0. And x minus 3 is the factor that goes along with the root of x equals 3. So in factored form, if I take x equals -2, that would be x plus 2, and it's a multiplicity of 2, so that will be squared. X equals 3 will be x minus 3. I skipped over x equals 1, that will be x minus 1, and then x equals 4 will be x minus 4. So that is my polynomial in factored form. What about end behavior? End behavior. The end behavior, remember we always start out with as x goes to -infinity, f of x goes to somewhere, and as x goes to +infinity, f of x goes somewhere. So if we look at as x goes to -infinity, that's the left end of my graph, and that is going up. So f of x goes towards +infinity, and as x goes to +infinity, f of x is going down, so that f of x goes to -infinity. Okay, next piece of information we can get out of this graph. How about the y-intercept? The y-intercept is where the graph crosses the y-axis. So that will be right here. Let's just call that y-intercept. I'll label it up here. And we'll just estimate that to be 0.49. Some other parts of this graph. Let's look at maximums and minimums. Remember that a maximum is a place where a graph turns around, kind of forming a mountain like the top of a peak there. And a minimum is a place where a graph turns around and forms a valley. So here we would have a maximum. And let's get an approximate. We'll say that ordered pair is about 3.5, maybe 18. When you do your activity, you'll be matching cards that have the numbers on them to the pictures, so it'll be a little easier than estimating. Let's estimate this minimum to be at 2, and then maybe -32 or so. Then we have a maximum here again at, let's say -0.5, and then 54. And then here we have a minimum, and that one's easy. It's at -2, 0. Okay, another feature of our graph, we will want to talk about where the graph is positive and negative. So remember that positive means where the graph is above the x-axis. And negative means where the graph is below the x-axis. And the graph switches over from positive to negative. So it switches over from being above the x-axis to being below the x-axis at the x-intercepts. So we might want to take note of those. The switch is at x-intercepts. So our graph starts out being positive. So from negative infinity up until -2, it's positive. Now what happens at -2 is that the value of the function is 0, which is not positive or negative. So we always want to skip over our x-intercept values. So the graph is going to be positive from negative infinity to -2, and then we skip over -2, and it's still positive all the way till we get to 1. And then starting after the x value of 1, the graph is below the x-axis, so it's negative from 1 to 3. And then it's positive again from 3 to 4. And then it dips back below, so it's negative from 4, and then all the way out to infinity. Another concept that we want to review is increasing and decreasing. Increasing, just to refresh your memory, means that the graph is going uphill, and decreasing means the graph is going downhill. So on our graph actually starts from the left-hand end. It's decreasing at the beginning, and then it turns around at this point right here and begins increasing again. And then it turns around again and begins decreasing until it turns around and begins increasing again. And then it turns around and begins decreasing. So our graph is changing from increasing to decreasing a lot of times. You might want to make note over here that it switches. So the switch here is at anytime you have a max or a min. So again, we will give our intervals as x values. So it's decreasing from negative infinity up until the x value of -2. So negative infinity to -2. And then it begins increasing. It increases from -2 until it turns around right here. So from -2 to -0.5 was our estimate. So it's increasing from -2 to -0.5. And then it's decreasing starting at -0.5. It decreases until this turnaround, which is at x equals 2. So positive 2. It's decreasing, and then it's increasing from 2 to 3.5. And then it's decreasing again from 3.5 to infinity. That should be a comma. 3.5 to infinity. I think that's all of the information you will need to get through the activity, where you will have 4 of these graphs, and you'll be matching them up with cards that have positive, negative, maxes and mins, y-intercept, end behavior, increasing, decreasing, the roots, and the factored form.